Hello, today we're going to look at factoring, common factor and difference of squares. And there's actually also a third type, but for some reason it didn't make it into the title. But don't forget what factoring means. Factoring is going from a sum to a product. So for example, 2x plus 2y is a sum, and I can rewrite it as 2 times x plus y, a product. So that's going to be our goal for this section. The first thing we're going to do is we're going to look at factoring out the greatest common factor, generally called the GCF. So the GCF is the largest, hence greatest, factor that each term has in common. And the first thing we're going to do is we're going to look at the coefficients. We're going to look for the GCF of the coefficients of each term. Then we're going to look at each variable that appears in every term. Remember, it has to be common throughout every term. Every time there's a plus or a minus sign, those are what separates terms from other terms. And when we look at the variables that appear in every term, we look at the smallest exponent that it's raised to. So, for example, 12xy squared plus 6x squared y squared minus 8xy cubed z. We start by the coefficients, 12, 6, and 8. What do they have in common? So 12, 6, and 8, they are all even. So when I start looking at the GCF, they have a 2 in common. 2 is the only thing they have in common. 6 and 8, there's nothing else besides the 2. If I looked at 12 and 6, just the first two, I could pull out a 6. But there's no 6 in the 8. So you got to make sure that it's in every single term. Next, we look at the variables. So if we notice there is an x in every term, I'm kind of crawling over this, but it's okay. The smallest exponent we see it raised to is 1. So there's an x in our GCF. Then we can move on to the y. Every term has a y. And the smallest exponent we see it raised to is squared. Our third term has a z, but there's no z in the first two terms. So the z is not part of the greatest common factor. It's not in common to all three terms. So our GCF is exactly 2xy squared. The next thing we do is we factor out the GCF. And this amounts to dividing the expression by the GCF. So we take our original expression, divide it by 2xy squared. And if I divide 12 by 2, I get 6. X divided by x is 1. Y squared divided by y squared is 1. So the first term is just a 6. Then I look at my second term. 6 divided by 2 is 3. X squared divided by x is x. Y squared divided by y squared is 1. So my second term is 3x. And then my last term, negative 8xy cubed z divided by 2xy squared, will give us negative 4yz. The answer, remember, has to be a product. So we multiply the GCF by our quotient. And our answer is 2xy squared times 6 plus 3x minus 4yz. So again, the really, really important part is that if it tells you to factor something, your end result, your answer has to be a product. So let's try another one. 4ax squared minus 6a cubed x cubed plus 2ax. So if we look at the coefficients, 4, 6, and 2, we say they have a 2 in common. So the 2, the 6, and the 4. And then we look at the variables. There's an A, an A, and an A. So the A they have in common, the lowest exponent is a 1. And then the other variable they all have is the x. The lowest exponent is again 1. So the GCF is 2ax. When I take my expression and divide it by 2ax, my first term gives me 2x when I divide it. My second term gives me 3a squared x squared. And then my last term, remember, 2ax divided by 2ax. We sometimes say they cancel out, but remember, they cancel as a 1, not a 0. So when I write it out, I have 2x minus 3a squared x squared plus 1. I've got 3 terms here. I need 3 terms in my answer. So remember, 2ax over 2ax is 1, not 0. That's probably the thing that I see the most that people get wrong. They say, oh, it cancels, and they're done. But it cancels as a 1. And then again, the answer has to be the product of these two things. So 2ax times 2x minus 3a squared x squared plus 1. So let's try another one. 90p cubed minus 15p squared plus 30p. If I look at the coefficients, 90, 15, and 30, my GCF starts with 15. 15 goes into 90, 15, and 30. I've only got one variable, and that's p. The lowest exponent I see it raised to is the first. So my GCF is 15. Again, my next step is to take my expression, divide it by 15p, and I get 6p squared minus p plus 2. And again, my answer is the product of these two things. Another type of factoring we're going to look at is the difference of squares. So if we recall from Math 110 or whichever equivalent you took, 100, 105, 106, there are like 20 different versions of it now, but your intro to college math, we learned that x plus y times x minus y equals x squared minus y squared. This is called the difference of squares. Right? It's a difference because we're subtracting, and we're subtracting a square from a square, so the difference of squares. We're going to be using this backwards to find things, to factor things that look like x squared minus y squared. Remember, in 110 we went this way. Now we're going backwards. We're going from the sum to the product. So whenever you're asked to factor things and you have two terms and they're being subtracted, the first thing you want to ask yourself is, are those two terms both squares? And if they are, we can factor it. So for example, x squared minus 16. X squared is a square, 16 is a square. So I can factor it by just taking the square root of each of them and then adding them and subtracting them. So the square root of x squared is x, the square root of 16 is 4. So x plus 4 times x minus 4. Here's another one, 25x squared minus 9y squared. They are both squares. If I square root 25x squared, I get 5x. And if I square root 9y squared, I get 3y. So I can factor it into 5x plus 3y times 5x minus 3y. Don't forget that the really nice thing about factoring is that it's undoing a process we already know. So I can always multiply this out and make sure that I get what I started with. So there's absolutely no reason to get this wrong because you can always check your answer. Here's another example, 20x squared minus 45. So I have the difference of two things. But if I look at them, I say to myself, well, 20 is not a perfect square, neither is 45. So I can't do the difference of two squares yet. But what I do want to look at is the GCF. Don't forget about the GCF. That should always be the first thing you look for. So 20 and 45 have a 5 in common, so I'm going to factor out the 5. And I've still got two terms, but now both of those terms are squares. And I can factor them. 4x squared becomes 2x, 9 becomes 3. So I still have the 5 out front, and then I've got 2x plus 3, 2x minus 3. 36a squared b squared minus 169c squared. All of my variables are squared. 36 is a square, 169 is a square. So I can square root them. The square root of 36a squared b squared is 6ab, and the square root of 169c squared is 13c. So I get 6ab plus 13c times 6ab minus 13c. 36t squared minus 121t to the fourth. Again, I am going to start by noticing that there is a GCF. T squared I can pull out. So I'm going to have t squared times 36 minus 121t squared. Both of those are squares. So I have my t squared and then 6 plus 11t times 6 minus 11t. You might not have noticed the t squared at first because if I look at them individually, 36t squared and 121t to the fourth, they're both perfect squares. So I could have gone directly to the perfect squares and said, well, this is equal to 6t plus 11t squared times 6t minus 11t squared. But then you should always look and ask yourself, am I done? And say, well, there's a GCF here, they both have a t, and there's a GCF here, they both have a t. So if I pull out a t from each of them, I will get back what I had over here. It's usually faster to look for the GCF first before you do anything else. So always try to look for the GCF first. But if you don't, remember to at least look for it later on. Okay, so now we're going to look at the other way, which didn't actually make it into the title. And this is called factoring by grouping. It's going to be really important when we start talking about factoring trinomials in the next section. So factoring by grouping is used when we have 4 terms, and you, again, always want to make sure that you factored out any possible GCF. So, again, you need 4 terms for factoring by grouping. So 2x minus 2y plus ax minus ay, 4 terms. There is no GCF. There's no factor that every term has in common. So what we do is we group these into 2 groups of 2 and then factor each of those separately. So we group them into 2 groups of 2. So 2x minus 2y and 8ax minus ay. Typically we're going to look at the first 2 and the last 2. So I can factor 2x minus 2y, it becomes 2 times x minus y. And I can factor ax minus ay, it becomes a times x minus y. We now have 2 terms, each of which has the common factor x minus y. When I do factoring by grouping, what I end up factoring out is not a monomial like it was with the GCF. Our new GCF, our new greatest common factor, is actually a binomial. So notice they both have x minus y. So I'm going to factor that out. And what I'm left with is everything that's not underlined. 2 plus a. So I have x minus y times 2 plus a. So we're going to do a couple more examples like this. 2y cubed plus 5y squared minus 6y minus 15. So again, I have 4 terms. There's no GCF, so I'm going to group them into groups of 2. 2y cubed plus 5y squared, and then negative 6y minus 15. If I look at my first group, I have a GCF that involves my variable, and if I look at my second group, my GCF involves a negative 3. So I pull out my y squared from my first group, I pull out a negative 3 from my second group, and then you ask yourselves, well, what do my now 2 terms have in common? And here's where I have 2y plus 5, 2y plus 5. That is my new GCF. When I factor it out, again, I'm left with everything that's not underlined. So I have 2y plus 5, and then y squared plus negative 3, which is the same as y squared minus 3. Okay. So let's try another one. 2z minus z squared plus 12z cubed minus 6z to the fourth. There is a GCF here, so we got to make sure we take it out. Coefficient-wise, there's nothing because of the lovely 1 that we have there. But they each have at least a z in it. So I'm going to factor out the z, and I'm left with 2 minus z plus 12z squared minus 6z cubed. Again, I'm going to separate it. 2 minus z is my first group, 12z squared minus 6z cubed is my second group. My first group, I can't factor anything out. 2 and z have nothing in common. But to make it look a little nicer, I'm going to factor out a 1. For my second terms, my blue terms, there's a 6 and a z squared that they both have in common. So I'm going to have z times 1 times 2 minus z plus 6z squared times 2 minus z. And here again is the 2 minus z that we have in common here. So I'm going to pull that out, and I'm left with the 1 plus 6z squared. So again, don't forget, the 2 minus z's cancel, but I'm left with a 1. I had 2 terms, I still have 2 terms. Okay, so whenever you do factoring by grouping, you're always going to end up with a binomial times a binomial type thing. You're never going to have a monomial. Your GCF will always be more than one term. So get one last one to look at. So 4p squared minus q squared plus 2p plus q. So I'm going to break it down into the first 2 terms, the second 2 terms. Notice my red terms, 4p squared minus q squared, it's a difference of 2 squares. So when I factor it, I'm going to have 2p plus q, 2p minus q. And again, my blue terms, 2p plus q, don't have anything in common, so I'm going to factor out a 1. And then my now 2 terms both have 2p plus q in common. And when I factor that out, I'm left with my 2p minus q plus 1. So it's a binomial times a trinomial in this case. Okay, but again, it's never going to be a monomial if you're doing factoring by grouping. Okay, so try out the homework problems, read through the book, and let me know if you have any questions. Good luck.